this video, we go to the second part, follow the Octave menu. We will do some simple examples in Octave after we already set up and configure the installation of Octave in our Windows operating system. If you are using the other type of the OS, I hope you can follow the guide in the Octave website to install either in OS, the Linux OS, or in Mac OS. For this video, we will go to the left part is the Octave interface, and the right I want to share with you. I have made some update about the GitHub repository. Now within the repository, here is the Octave, the website, and I put our simple table for you. So this is the menu which we are going to follow in our learning series of videos, and you can go to here to download directly from the documentation of octave.org, or within my the repository. I download all these file offline, so you can also get this file always in case the link from the Octave site may be changed. Similarly, here is the reference link, quick reference, and the reference card, so you can also get this. We will mention this later on when we have some initial understanding of Octave. And I will keep adding the videos into this YouTube channel. Also, because Octave is in somewhat named as the alternative for MATLAB, I also give you some other choices if you are interested for the MATLAB related the application. So Julia, NighTPy, Scilab, and the Sigmas, which you can also go to the link and to get some information from that. After Octave, I hope I can also arrange some specific video the link captured for those learning and to share with you the practical experience. And here is the mind map. I will keep updating of them. And if I switch to the mind map, you will see here gradually. I don't want to repeat this menu, but the key thing is differences within mind map. I may add some the links for the reference. And also, I may just capture some key information for different chapter. So this is the just export our image, and this is the source mind map file, which in our repository is this file, so that you can open by free plan to get more detailed reference. And for this video, what we want to go through is we already able to run the Octave. And when you run the Octave, I want you to have some the key, the shortcut remembered. You can always use Control-C to interrupt one operation. So if there's some the wrong iterations or looping, so you can stop that. You can clean the command window by CLC. So for example, if I put 3 plus 5, 6 is this one, and you use CLC, then this command window will be cleared. And at any time, you can use Control-Z in some OS, or use quit or EXIT, then you can quit from the Octave. And also some UI perspective is within last video we did some the command. So you see the command history here, and we within those command we create multiple variables. So all the variables are stored in the workspace. So those one, if you click edit, you can see 3 options. So you can click clear command window like this CLC, and you can clear the command history here. You can clear the workspace. So when you want to do some the new the practice, it's better you keep your history and the workspace clean. And this one is your working the folder, so you can change working folder here, or you can use last time is you can use a CD change the directory command to do that as well. So what we will going to do this part is we will have some simple example. So we already mentioned this Euler identity last time. So this means you have some elementary calculation. So I put that here. So for the elementary calculations, you can use plus, minus, multiply, division. So if you divide 6 by 5, you get 1.2000. So normally it's a 4-digit in this precision level. You have this 4 with this upper arrow with 2, and that means 4 times 4, so, or 4 is 3. So you can see here, answer is just one variable in your workspace because I don't create any variable. So if I put is f equal to 6 times 5, then you can see here you're starting to have rf, and all your history is here. So I can remove those history and clean the workspace. And the natural log or the natural exponents. So we use Euler is already practiced this one. So I times I. So that is our Euler's identity. So you use this EXP. So we can also use the log. So you got this log 23 with the 10 as the base of digit for the this logarithm. And also you have some these trigonometric functions. Sine is like we put is sine 45 or sine 0.5 times pi. So I got this. You can have those the different way to make that sine, cosine, and also real and imaginary number. So that is a complex things. If I say here, a equal to 2 plus 3i. So that is first imaginary number, and b equal to 5 minus 2i. And I put the c equal to a plus b. So that is should be the real part, the add, and the imaginary part add. So that should be the 7 plus 1i. So that is the thing. So you can also practice a times b. So that is will be the complex way, but that follow the mathematical the rules. And also we have some constants. So if you put, if I put e, so that is 2.7183. So if I point the pi, so you got this. So those are the things you can always use them at any time. So if I use 2 pi, so that I got 6.28. So that's the elementary calculation. And if we move to the second part, is we can very easily to manipulate matrix or doing the matrix arithmetic. So let's use the CLC. So you can clear your command window, and let's use this the square brackets that will define our matrix, and use this you can see here. Use our comma. So this is the comma. All space you can define one line of the matrix. And you use this semicolon to or use our carriage return. You can create this second line. So let's starting from the basic. So if I put this A, normally matrix we use the capital the variables. If I put this 1, 2, 3, I use a space. Then I got this the one line with 3 column. You can also use B is 2. This with our comma. With a comma, you get this one. Actually, you can use this like this 1, comma, 2 with a space, 3 with a space, 4, comma, 5. You can also get this, so which means you can mix them, but I don't recommend you use this way because you also need to ensure is you don't make any human errors. So if you stick one of the method, you just continue use that. No matter. So then if I create this D is if I use 1, 2, 3, and with a semicolon, 3, 2, 4, 5, and 4, 5, 6. So you don't need to have this semicolon in the last. So let's do like this way. So you get our 3 times 3, the matrix. But let's try. So if I use this in the last, actually, you don't get any error, but let's see here is the size D means you get this the big amount of or the size on your matrix is still the 3 times 3, so 3 rows, 3 columns. So this one is also is ignored or no matter, but I also don't recommend you use that in the last, because that's if you happen to have another the numbers, then you will get an error, because this intends to create the 4th row, but you don't have the enough digit, so vertical dimension mismatch. So you need to make that 3 times 3, but looks like it's here is 1 times 1. So that is the thing you need to have some idea to be noticed. And then it's, we can create some random using this the function random 3, 2. Then the you get our 3 row 2 column matrix with each element set to our random value between 0 and 1. So those are the things. And if you want to make this random value is between the 6, so you can see here. So you just times 6, then you get our the random value between 0 and 6. So same as if you want is 0 to 10, so you get the this one as well. Every time you create that, you will get another random matrix as the result. So when you create that, another thing is you can create this or this kind of the command, but if you finish that with a semicolon, you have nothing to export. But that means you create that and you don't want to display. Sometimes when you create a large number of the metrics, so data set, you just want it silently created. So you use this, and if you want to see that the result, you just type B, your variable, and this one will come in. And this workspace is very useful. If you expand that, you can see here, you create something, then they give you the dimension. So this dimension will tell you like B is a 3 row, 2 column, and it's also show you the value. So you can see here, and normally it's use this comma and the semicolon. So you'd better to follow this as well. And here is the attribute. Like our small a and b, they tell you they are the complex the number or type you are using. When I do C is a times b, I got another complex type. So using this workspace, you may get more information easily by your the variables. And the metrics can also be used like I already used this way. So this is a matrix. I use that to times 6. That every the single value is times 6. And also you can use the like A is random times 3 3. B is random 3 3. So I got this 2. Then I use A plus B. So you get this this one plus this one. So everyone A minus B. So you get because it's very small. So that will be. So let me make that times 10. Then A minus B. So you get some the not so small numbers, and A times B multiply B. So you got that is the matrix multiply, and also we have this matrix product. So we cannot have this T like this way. So within the Octave is introduce this. You can use this way and use this left the times A to use this code, single code. Then you got this value. So that is the some the notation you may remember, but we will practice more during this linear the algebra the sections, and also we same is way to some linear equation. Use this A with this left division operator to do some formula. So if AX equal to B, then X is A left division B. So that is similar, means is A's the power with minus 1 B. So that is the way is like B divided by A. So we use A left division of B. This way is most of the time is used for a very interesting the balanced chemical equation the solving. So here is H2 plus O2 go to our this water, so H2O. The equation above is not accurate because it's not balanced. So what we will do is we will have a tool, the function to trying to do this. So if we use x1, x2, and with the final result, so h will be the 2x1, 0x2. So then here is 0 because 0 H2, so then plus 2. So number is H is 2, and 0x1, 2x2, 1 is 1 O. So that is oxygen. So then we have 2. We can use this matrix to do that. Let's practice. Is A equal to just the 2 row, 2 column. So we use the first row is the 2, 0. Second row is 0, 2. And what we use our semicolon because we don't want to show that now. So, but if you want to show that, A is this one. So we use small b is the result with 2, just the 2 rows. So we use a semicolon and 1. So b is this one. And then x is equal to big A left division small b. So x is 1, and first row is 1, second row is 0.5. So that is our result for this the balanced chemical equation. So, and then there's integrating the differential the equation is like this way. So we don't need to repeat this. You can read this 1 to 5 here, but this way we will mention in the real chapters in more detail. And then I just show you a little bit about this the graphical output. And show you how easily they will do. So what I need to do is we still need to use these functions. So let's make this function, but not the purpose for this 1.5, but just try to practice this one. So we build our function. And when you make our function keywords, when you enter, you will see the prompt is not showing, and it's just waiting you adding the lines. And here is I don't see we can have this blank line because you cannot enter. So you just give the parameter R, K, A. Use the semicolon, B, C, D. So we have all of our parameters. Then we do some the formulas function. So R times x1. You can use a space between those times to make that easier reading. X1 divided by K is minus A times X1 times X2 divided by E1 plus b times x1. So that's the first function. Okay, so I think it's we did some wrong. So let's again. So I put this x dot 1 0. So. Okay, I retype until here, and you have another keyword and the function. So this way you finish to create your function or define the function. Then we use x0 is 2 rows. Actually, so you can show x0 is this one, and t equal to line space. So that gives some calculation. It's from 0, 50, 20, and 200 with this code. Then x is ls as thought is using this our function with x0 t. So we can show x is this, t is this. So let's clear our part. So those are the 1.5 for this differential equation calculation. But what we will use now is we have our t and x in the memory. So let's try to plot t with x. So if you use this way, you can have this. So this I also put that into the mind map. So if you generate the same the plot, then congratulations. So you have created the correct formula and within the function. So this is two lines with x and t, and you can use close here to close your plot. And also normally sometimes we use this semicolon so as well. So you can have this one. So same as the part, and within the plot you can have this the grid line. And I think it's a toggle your boundary, but normally you can keep that. And this one is insert text. So this is my 1.2.6 plot. So for example, you can make this here, and then you can save as. When you save, it's save to the different this you can save to the PDF, save to the JPEG, and when it's opened. To save this have displayed, so you can directly use print. So if I close this, and I already have this print to, and let's do this print again, PDF. If you don't have no figure, so you need to make that displayed, and let's make our test. So with this opened, let's print. So it's just waiting some seconds, and when they back, and you will have our the file. So it's finished. Then let's go to our file. You see here. This means exactly as mentioned. Your also the customized text is here. So that means you can export that easily. And also, if you don't use that print command, you can use this way. So you can print to our Octave figure, or you can print in some other. Let me print to our PNG file. You see here is coming to our PNG untitled. So this is our the plot. So ensure is you don't have that closed. As I mentioned here, if you close that first, then there's mentioned no figure to print. Arrow is code from this one. So now you can close that. And you can also do some help on the print. So you can also use the help to print. Then you get some description like the man page in Linux or help in the 1.2.7. It's a plot. Then you can read these parts. So that is the part is you can try to practice, and at the same time is you can also use the documentation tab. So from here you can also try to find the plot. You can see plotting. So introducing the plotting. So those are the detail, the menu that we have some getting. So what we have doing now is we are also just trying to practice this during our learning. So if I say here, you can see all this what we practiced is already mentioned here. So this documentation is just this menu. And then the edit, what you have done, so you can use some the different words, the keywords. So I also put that here for your reference. So you can see here, edit. You can have the Control P to recall the previous command, Control N to the next line of input, Control B to backwards, and Control F is forward. So just maybe I use Control P. So you can see I just whenever I type Control P, it's similar like this. So let me see here. You can use just the upper the arrow, then they will give you the downward arrow. So just you can switch here, or you can click this. Just double click, it will run in this one, and you close that. Then it's the same as this close button. So those are the things you can have some trying. And the 1.3 is some conversion. So I will just use this video to finish this. You can see some different way that we within this menu what certain the conversion we will use. So I hope within this video we have done the draft these simple examples, and from next video we will go to this getting started and to see some more interesting practice altogether. See you then.